2025. I am very blessed that so many people are joining us around the world, and it's a big pleasure for me that I received the confirmation from Dayana, a colleague of mine, who supporting us this year with the Wind and Solar Synergy Week and provide us with a talk with the name From Renewables to Hydrogen, Navigating Through Green Hydrogen Sustainability Standards and Regulatory Frameworks. Dayana is an electrical engineer whose work between the global research, renewable energy innovation, and the advancements of just energy transition. My colleague Dayana completed her undergraduate degree in electrical engineering before she's continuing her academic journey in Germany. She earned her Master of Science in Electrical Communicating Engineering from the University of Kassel, where her master's thesis focused on renewable energy and power electronics. She's now a researcher at the Fraunhofer Institute for Energy Economics and Energy System Technology here in Kassel. And her core areas of expertise include green hydrogen, power-to-X technologies, and system integration, and the socio-technical aspects of the global energy transition. In her current role, she's especially engaged in the development of training programs and certification frameworks in three major international hydrogen projects. And these are the projects HySecunda. This is a German-South Africa partnership. And there, Dayana is responsible for designing and implementing training modules tailored to the local needs and supports the development of certification strategies for hydrogen production and infrastructure. In the Power-to-Magma project, this is a German Chile project. She's also responsible for capacity building and for the development of training programs. And in another project, which is called High Uruguay, she's doing this project in cooperation with the University de la República in Montevideo. And in this project, she's responsible for the development of a research roadmap between these partner universities, also for the topic of green hydrogen. This talk, or the whole session, the duration is 50 minutes. And now Dayana will provide you with a talk of around about 20 minutes. And after that presentation, you will have the chance to provide Dayana with some questions about her presentation. And before we start, I would like to introduce two master programs, and these master programs are responsible for the whole conference. The first master program is a program which is called Solar Energy Engineering. It's a master program from the University of Freiburg and the Fraunhofer IWSE in Freiburg. It's a completely online program with 120 ECTS. And I highly beg you to go to the website of the study program, make a little research about the different modules they are offering in Freiburg, and maybe if you are interested in topics like or which are dealing with solar energy, I highly recommend you to go a little bit more into the research. And the second program, which I'm responsible for, is a program for wind energy systems. This is also a master program of the University of Kassel and the Fraunhofer IE here in Germany. As I told you before, it's also an online program with 120 credits. And we do have two specializations. The first one is dealing with energy system technology, the other one with simulation and structural technology. And same as the other program in Freiburg, I highly beg you to go to our website and have a deeper look on our different modules which we are offering. And if you are interested, then I beg you also, of course, to apply for this master program. But now, I think I do not want to make so much marketing for our master program. The focus now is on the topic of certification of green hydrogen, and therefore I would like to deliver the presentation to my colleague, Dayana.
Thank you, Andre. Thank you so much. I think I'm going to share my screen first. Can you confirm that you can see my full screen?
Perfect.
Yes. So first of all, thank you, Andre, for your introduction, and thank you for the invitation. I'm very happy to be here with this topic that, first of all, is very important for me, and second of all, is it makes fun for me to work with this topic. I just have this presentation which I called From Renewables to Hydrogen, navigating through green hydrogen sustainability standards and regulatory frameworks. And with that, I would like to go further with a short agenda. First of all, I would like to bring you in the context why it's important green hydrogen and power-to-X products, which is the role of them in the decarbonization of sectors. Second, I would like to talk about a little bit about sustainability criteria in the green hydrogen context. And then I would like to bring you in the context about regulation and certification schemes. Let's do this. Let's start with the first part, which is to achieve climate neutrality. We all know that climate neutrality right now is a deal that all countries and regions are committed to. And you know that there are many pathways or some pathway to decarbonize sectors. If you see here this picture on the right side, you can see that there are the pathway of energy efficiency. We can use it according to the sector, for example, building, transport sector. We can also use renewable energy as a pathway to climate neutrality, which can be applied in sectors, for example, in the power sector. There is also electrification, the pathway, which can be applied to a mobility sector and in some industry sectors. But if you see this picture graphic, you see that there's still here a gap to achieve this net zero target. And that is where the power to X products or green hydrogen and power to X products have their role. That means that the green hydrogen and power to X products, they play a very important role in decarbonizing sectors, which are very hard to electrify or very hard to abate. They could be sector, for example, in the industry sector, just as the chemical industry, or mobility sectors, for example, aviation or shipping sector. But the new is that this power to X market is in a very in the beginning stage. That means that it's very important for a market that is in the beginning stage to have policies, to have some kind of reliance that the market could go further. It is also important that not only climate neutrality should be achieved, but also it's important that new markets and climate neutrality also contributes to just energy transitions. For that reason, it's important that power to X policies, power to X sustainability criteria just come in this role as well. I really like this picture here that I'm highlighting to you because it shows four important not pathway, but characteristics and aspects that should be considered if we, for example, want to achieve not only climate neutrality, but just an energy transition as well. So we need to consider environmental aspects, for example, water, energy, what kind of energy I'm using. We also need to consider economic impacts. We want to bring a added value to the new market that we are introducing. We also need to have clear governance. For example, how is the policy commitment? How is the government commitment with the targets? And we also, I think it's very important, we need to consider social aspects. Are we considering human rights? Are we considering access to energy rights and so on? For that reason, there are priorities that should be accomplished when we are introducing to this market. And one of these one is we need reliable regulatory frameworks for this green hydrogen and power-to-X products or market. We need to define the credible sustainability standard that comes with sustainability criteria. We need to establish certification schemes in order to know how our requirements can be certified. And at last, and it's very important also, we need to have a full integration of financial incentive, but also full integration with financial incentive and also economics in the region. So now you can ask me, but why is this so important? So I already talked to you that green hydrogen products and power-to-X products are very important to decarbonize some sectors that are very hard to decarbonize. First of all, that means that right now many countries or many governments are pushing companies or pushing the regions to achieve this climate neutrality. And that means that the global demand, for example, in this part of green hydrogen and power-to-X products is expected to increase in the following years. Why I'm mentioning the governments? Because this demand is triggered by the regulation frameworks or the mandatory frameworks that companies, sectors, industries should accomplish or should comply in order to receive financial incentives, for example. For that reason, if we have these three first drivers, if I can say that, we need a confidence in the market, especially if this is a beginning market. So it is important that to grow with confidence in the green hydrogen and power-to-X market, we need certification and we need also sustainability criteria. We need to prove that these sustainability characteristics are complied according to mandatory frameworks, depending on the regions. Now you can ask me, okay, but how or which are those sustainability criteria? So let's talk about a little bit what we have found in different international projects that we have worked on. We have realized, or we have categorized, if I can say that, the important sustainability criteria concerning to the production of green hydrogen and power-to-X products between three categories. The first one is the power supply criteria. This power supply criteria includes other sub-criteria, which I'm going to explain you in the next slides. But these power supply criteria are there to define how should be the connection, how should be the supply between the renewable energy source and the green hydrogen plant, and how should occur that? Which are the specifications? The other one is the category of environmental aspects, which includes other aspects. In one of these, which is very common in most of regulation and certification schemes, is the greenhouse gas emissions reduction, but there are other environmental criteria that are also considered. And the third category is the social aspects. We also need to consider social aspects such as labor condition, community health and safety, and so on. I would like to explain a little bit the sustainability criteria. Let's start with the power supply requirements. I said that the power supply requirements are those criteria saying or setting out how the green hydrogen can be produced. How is this technical configuration? How should that happen? There are three important concepts: additionality, temporal correlation, and geographical correlation. According to regulatory frameworks and certification schemes, the production of renewable hydrogen should comply in the power supply requirements with these three criteria. Not for all frameworks, but some of them, they say they need to comply with these three criteria. So what is additionality? Additionality is telling us that it is important to incentivize new renewable sources. So in the sense of that we are not taking green electricity that are destined to other sectors. So we need to create, or we need to support for our new capacity for us, as an example. Then comes the principle of temporal correlation, which is saying me the framework or the time period, the period in which my production of green electricity and this production of green hydrogen is occurring. Could be hourly, could be in a year, could be monthly, and so on. That depends on the regulatory frameworks and the certification schemes, international, worldwide. And the other concept is geographical correlation. This concept is telling me right now how, in which space is located my renewable energy source and my green hydrogen plant. Where are they located? Are they in the same region or not in the same region? The idea of this geographical correlation concept is also incentivize this new electricity or green electricity in regions. So to have more renewable energy shares in the matrix. Now I would like to show you that it's also important to consider in power supply requirements and how it's defined depending on these regulatory standards and certification schemes, how is defined the connection between the renewable energy source, but also the green hydrogen plant. This connection could be direct connection, as you see here in this graphic, but it could be also indirect connection through a PPA, which is a power purchase agreement. You can connect it to the, I mean, you can take green electricity from the grid, but you need to show this power purchase agreement. So to showing that you are using green electricity and not somewhere else grid electricity. But there are also the possibility, not in all certification schemes, but it is also the possibility that one certification scheme of framework say that you can connect your electrolysis plant or green hydrogen plant to the power grid. These two slides that I showed to you is about power supply requirements. But now I would like to go just a little bit the environmental and social criteria. But let's start with environmental requirements. Usually, it's very important for certification schemes, or they define environmental requirements such as which type of energy we are using, renewable energy sources, which type of carbon source are we using? Is this carbon biogenic carbon, or is coming this carbon from industrial point sources? It's also important to take into account water, land, and biodiversity resources. I mean, the conservation of these three criteria. It's also important to consider which resources are we using to produce a product, but to be aware that there are scarce materials. I mean, do not use scarce materials. And if you do it, please, you need to have a mitigation plan, or you need to consider other aspects, for example, recycling. And there is also important the pollution risk and safety is very important in the sustainability criteria in environmental categorization, but also they are not named here. There are other covered areas such as the noise quality or the noise decibels. The air quality is also very important to keep into account the threshold that are allowed, depending on the region or depending on national and local laws. And greenhouse gas emission savings is one of these environmental requirements, which is, I think, mentioned in all of the certification schemes, giving us the percentage in which the green hydrogen should be produced and the greenhouse gas emissions reduction related to this green hydrogen. Now, the social requirements is very important to consider that we don't want to enter in conflict with our communities. So we also need to check how is the access to energy, access to other resources such as water. Water is a very critical how can I say that very critical social requirement when they are afraid that they suddenly don't have water for themselves, but also there are other criteria such as human rights, labor standards to comply with health and safety technical criteria. We also want to improve, or we want to support the jobs and the skills of the personnel of our community by giving employment or giving some new trainings, for example. And there are other further covered areas such as involuntary resettlement. We don't want to, it's a little bit related to access of resources. We don't want to enter in conflicts, land conflicts with communities. And this year is very important. I already mentioned that it's very important to consider the compliance with national and local requirements and laws, environmental and social laws. That was about sustainability criteria, but now I would like to go into the topic of regulation and certification schemes. It's a very vast, how can I say that, vast topic. Those are here, I mean, a summary of the international regulatory framework, certification scheme, and market incentive mechanism that we have analyzed through our international projects. Some of them are general standards, which they need to be considered for example, environmental and social safety guidelines, but also to be considered because we want this just energy transition, and most of the certification scheme, they also relate themselves and the criteria to the Sustainable Development Goals. Those are general standards, but also there are legal frameworks. If you can see here, I mean, legal frameworks are very different depending on the region, and they have very different criteria, different assumptions. So they are at the moment not in a harmonized way designed. Legal frameworks are normally mandatory depending on the region. There are other part of categorization, which is the voluntary certification schemes. Those are those schemes that are there or serve as a guideline or guide to prove or certify the requirements imposed by the legal frameworks. And there are also market incentive mechanisms, which are those, for example, financial mechanisms that project developers can obtain in order to implement green hydrogen or power-to-X projects. I say that this is a very vast topic and with many different requirements depending on the region, depending on the legal framework. I would like to focus myself just shortly about the Renewable Energy Directive, which is the RED III here in Europe. But first, I would like to show you a little bit how can you imagine this legal framework, certification scheme, market incentive mechanisms. If you can see here, they have different, for example, greenhouse gas emission specifications. They have, for example, different methodologies. They have different assumptions. They also have different thresholds that the green hydrogen should comply. If you see to the other side here, which I'm pointing out, you see the same power supply criteria, environmental, social requirements, and you see that they are also not harmonized, which many of them, they consider environmental criteria, as you see here, but other of them, they don't consider environmental criteria or social criteria. This is how it looks like, but as I said, I would like to focus on the Renewable Energy Directive, which is the RED 3. And with the RED 3, I would like to introduce about the delegated acts. How can I say that? The delegated acts is this such group that they are in charge to create the requirements and the rules under which green hydrogen should be produced, must be produced. First of all, in the Renewable Energy Directive, they talk about the concept of renewable fuels of non-biological origins, which we think of then is the green hydrogen included. And it's not all the certification or regulatory schemes have this definition. Some of them they have, but this RFNBO is specifically a definition from the Renewable Energy Directive delegated acts. This delegated act has two articles. In these two articles, they are defining, first of all, in Article 27, the specification of the renewable electricity and how should be the green hydrogen produced with this renewable electricity source. If you see here, they call this as a power purchase criteria, which includes criteria such as the renewable energy source, additionality, temporal and geographical correlation. I already mentioned that. And there is the Article 28, which is talking about which is the methodology to calculate greenhouse gas emissions, which value chain, until which part of the value chain I can calculate my greenhouse gas emissions, and how is the percentage of greenhouse gas emission savings. And also they give not only these requirements, but they also give the requirements for CO2 sources eligibility. CO2 sources to produce, for example, methanol, e-methanol, which are eligible to be deducted from the greenhouse gas emission methodology. I would like to go a little bit into the details with the Renewable Energy Directive and the delegated acts. So now you can ask me, okay, but you talk about connection type, to talk about additionality, temporal, geographical correlation here in the Renewable Energy Directive, but how is that then? The delegated acts in our Article 27, they also give us the requirements, how should be connected and in which scenarios should be the renewable energy source or the sourcing of electricity with our green hydrogen plant. So they say we can use direct connection. If we have direct connection, we need to comply with additionality. If we have indirect connection, which is possible, we have 4 scenarios that need to be complied. The first scenario is that you need a power purchase agreement if you are sourcing from your grid and you are sourcing green electricity from the grid. You need to have a power purchase agreement where you are saying that your green electricity is coming from which renewable source, and you need to comply with criteria such as additionality, temporal correlation, and geographical correlation. But how is that defined in the RED 3? So additionality is defined the same. The renewable energy plants should be new, must be new. Temporal correlation, very summarized, the period where the green hydrogen is produced. The period is right now until 2029 is monthly. And the geographical correlation is that the renewable energy sources and the green hydrogen production should be placed in the same bidding zone. That means in the same region or building zone in the same electrical connection. This is one of the scenarios from indirect connection. The other one is that, for example, if we are very lucky, as France, and our greenhouse gas emissions intensity from our grid is less than 18 grams CO2 per megajoules, we can connect our green hydrogen plant directly to our grid, but we need to comply with criteria such as temporal correlation and geographical correlation with a PPA. We also can use electricity from the grid if we have renewable energy excess electricity. And the other one that is very optimistic, and there are, I think, 4 countries that they can comply with this scenario, is the high share of renewable energy in the electricity mix, electricity matrix. They should be more than 90%. Countries, for example, as Uruguay and countries as Norway, yes, Uruguay, Norway, they comply with this criteria. That means they can connect the green hydrogen plant to the grid. And the good thing is that you don't have to comply neither with additionality, temporal, geographical correlation. They just give you a plus because you already invest in the past for renewable energy sources in your electricity matrix. And this one is the Article 28, which is about the greenhouse gas emission savings, which says that we need a 70% reduction of our green hydrogen. And that means that we need a threshold, greenhouse gas emission threshold of 28.2 grams CO2 equivalent per megajoules. The boundaries is well to will, which is mean that is the value chain all here that it needs to be count the emissions in our greenhouse gas emissions calculation. And at last, I would like to do a little bit marketing for our publication that we did. We published this, I think, 1 month ago. If you want to go into the details about sustainability, regulation, certification schemes, and all this work, and not only for the Renewable Energy Directive, but for other international certification schemes, you can also go to our paper, and here's the link. It's an open access publication. And then this is my contact, and thank you so much for your attention.
Yes, and I would say also thank you, Diana, for your very nice presentation. And I really like to follow your talk. And now I would like to beg the audience to provide Diana or us with some questions to her talk, or also, of course, to our 2 study programs. And there is the option to write your questions into the chat, but there is also the option to provide us or to turn on your mic and speak directly to us or to the presenter.
Diana, can you hear me?
I can hear
Yes.
you.
So I'm from the industry, so I have a question because we are struggling with this, let's say, the rules you just mentioned, and because at the end it makes hydrogen projects more complicated and more expensive. And we have a situation where we have renewable energies, or like, I mean, renewable electricity, where we have a lot of excess, already a lot of excess electricity, means electricity prices going to negative. And these 3 rules, which is additional temporal correlation and geographical correlation, becomes questionable, at least if the 2 first. So what is, I mean, of course, this is not a research topic, it's more a political topic, but at the end, if you, I mean, as a research, it's a question, if these rules don't, let's say, slow down the green hydrogen growth instead of promoting it.
Yes, that's a very good question. And I just forgot to say that, yes, the criteria, first of all, are very strict. Second of all, I know that last year, our Ministry of Industry, the other, Robert Habeck, they also sent a letter to the European Commission by saying that, first of all, the additionality rule is very strict. And the temporal correlation rule is also strict. They also mentioned something about the flexible allocation in the proposal, in the calculation of greenhouse gas emissions. And the idea is right now that also the Parliament is giving the task to the European Commission to make these rules flexible. Because as you said, that's right. Projects are slowing down. There are not so many projects that are reaching FID, for example. Financial incentive are also missing. I mean, the type or the amount of financial incentive. But as I know, yes, and political, I know that there is an incentive from the political side also to make this rule flexible. Especially for the additionality and temporal correlation and the type and how we calculate the greenhouse gas emissions for these power to X products.
Yeah, thank you. Maybe one small additional question is regarding if we have a strong focus on CO2 emissions. There's, of course, the alternative very much politically pushed from France to use nuclear electricity to produce low carbon footprint hydrogen and let's say forget about the colors. What about your opinion on that topic? If you think about, let's say, a future hydrogen economy and the best possible way to get there, is it a risk that we have this, let's say, producers of let's say not green hydrogen but low carbon, or is it a positive trend? What do you think?
That's I have discrepancies right now. But the first thing is that I know that the criteria, my point of view is that yes, the criteria is very strict. And my point of view is that some of the criteria doesn't make sense at the beginning of the market. On the other side, about, for example, this scenario that if it's possible to connect to the grid, if my emission intensity is lower than this 18 grams CO2 per megajoules, I will abate that because in my point of view, they are making too much noise to nuclear energy, for example. And I know that, I mean, this scenario or this criteria was accepted because, yeah, I mean, we all know that in the European Commission, in the European territories, France also belongs here. I think it was more political than environmental, if I can say that. But if we also read the Renewable Energy Directive and if you ask them, because you allowed this criteria, you allowed or you are making too much noise or incentivizing nuclear energy. And if you ask them, is there or there is nuclear energy considered as a renewable energy source? They deny that. But on the other hand, they incentivize this. So yes, that would be my point of view. It was more political than environmental oriented.
Thank you.
Yes, I can see two further questions in the chat. No, three questions. And
Yes.
the first question is in the additional, I don't know exactly, Diana, can you read the chat?
I think,
No problem. I can give the
I think I can
questions.
read, yes, the chat.
Yes.
Thanks. Okay. Thanks for the example. I have question the additionality criteria if one consumer is having a tied up with a generation. Okay, if a surplus power, I think that will be, I mean, that will be in the fall, in this case of imbalancement settlement, where we are producing more, or in the grid is more green energy produced, so we can take this electricity, or we can take the electricity in this moment. So in that case, we don't need to comply with additionality, for example. But yes, that counts, yes. And does that answer the question, Ashish?
Yeah, more or less, yes. And I would also like to understand whether, they need to set up a captive power plant on their own, or they can have a tie-up for the P. I mean, like you said, they can have a tie-up for PPA with the grid. But do they have the ability to, or the permission to set up a captive power of their own?
No, it's not only need to be captive. You can also take, I mean, you can connect from the grid and you can take surplus power, but you need to have an evidence that there was actually in that bidding zone surplus power.
Okay, understood. Thanks.
So the second one, there are some potential direct solar to hydrogen without requiring electrolysis. Expanding on previous question will be rules for. I cannot read. Expanding our previous question, will the rules be general enough for conservation of water? That's very interesting because, I mean, there are not many certification schemes that are considering conservation of water, but I don't think general rules for conservation of water, I don't think so. I think that depends of the region or the characteristics and aspects that the region has. Ross, that answer the question, or you want to complement something? Oh, thanks. And then Juan Paredes, which is the legal coverage? Okay, it's applied to both. One is applied to both. I mean, the REIT 3 criteria, they are applied for sure for plants, green hydrogen plants here in the Europe, but if countries such as, for example, Colombia or Chile, they want to export to here to Europe, they need to comply with this requirement. So it's for both. That answer your question, Juan?
Yeah, thank you. Thank you. I was interested more in the imports to the EU, if the origin of the hydrogen has to comply with those requirements as well.
Yes, they need to comply.
Great, thank you.
Yeah, thanks a lot. I think we do have still 5 minutes time. If there is some further question, please feel free to integrate your questions into the chat or give your questions directly in a vocal way to Diana.
Yes, hello. Thanks for your presentation. In one of your slides, I think it was the one related to Article 27, if I'm not wrong, about the PPAs. it looked to me that the last two examples, they don't require PPAs. Yeah.
You mean the example about surplus energy, surplus or electricity,
Yeah.
and the renewable energy share more than 19%, right?
Yes.
Yes,
Correctly.
they don't need this power purchase agreement.
Okay, fine. Thank you.
Okay, now I would like to give the room for one or two last questions to Dayana. Okay, in the moment, I cannot hear any questions, or I cannot see any question which was written or which is written into the chat. Then I would like to say thank you to Diane and to her very great presentation. It was very interesting, I think, for the audience, but also for me, because I really like that you or our institute is dealing with the topic of certification of green hydrogen. Next, I would like to welcome all of you to our next presentation in the Wind and Solar Synergy Week. I already mentioned or integrate this presentation of Mr. Frank Dinter from the Fraunhofer CSAT into the chat. He would like to provide you about an overview about the concentrating solar power, CSP, for hydrogen production in high irridance regions. And here you can see also the link to the presentation. And this presentation of Mr. Dinter will start in 8 minutes. And yeah, I think all of you will receive the presentation of Dayana. And now my last words are, again, thank you to all. And hopefully I will see, or we will see you in 8 minutes when Mr. Dinter will start with his presentation. Thanks a lot.
Thank you.